Welcome back, everybody. We're starting chapter 7. So in chapter 7 we're going to be talking about systems of equations, and in this video I'll tell you what a system of equation is. Our objectives today will be that you'll be able to solve systems by graphing, and that you'll be able to analyze special types of systems. I'll explain that later. Another objective is that you can define what linear equations are, solutions of systems of linear equations, and be able to tell us what no solution and infinite many solutions means. Okay, I want to talk about what a system of linear equations is. What it means is a system of linear equations means that you have more than one linear equation, so more than one line, and you want to see where those two lines meet. You also want to find out what x and y value could be plugged in to make them both true. So you have an x and you have a y. There is, most of the time, there is going to be an x and a y that if you put it in this equation, you'll get the same answer as if you put it in this equation. Okay? And I'm going to show you that, but first what we'll do is we're going to graph each line and see where they touch. So I took the first equation and I graphed it. I started at -6 and I went up 3 over 1. So this is my blue line. Now I'm going to graph this equation. Okay, notice what I did. I started at 2 and I went down 1, right 1. So down 1, right 1, down 1, right 1. And look at, they touch right here. So I need to find out what that coordinate is. It's over 2, up 0. So 2, 0, over 2, up 0 will work in both of these equations and give the same answer. Watch. I'm going to take the 2 and the 0. So I'm going to do 2 and put the 0 where y is. What is 2 times 3? 2 multiplied to 3 is 6. 6 minus 6 equals 0. Hey, look at this. We got 0. Watch what happens here. I take the 2 and I'm going to put it right there. So what's -2 plus 2? -2 plus 2 equals 0. Hey, it works. That's what these are. They're answers that will work in both equations and give us the same answer. They will be true in both equations, not just one. Alright, we have another example that we're going to write down to help us understand how to solve systems of equations. So again, I have two equations. I'm going to graph both. I'm going to see where they touch, and that spot where they touch is going to be an answer that would work in both equations. It's the one answer that works in both equations and makes them true. So this one's ready to graph. This one I'm going to get y by itself first. If you look, I got rid of a minus y by adding it to both sides. I got rid of a positive 1 by minusing it. So x minus 1 equals y. Okay, so now what I'm going to do is graph both of these. Let's look at how I graph these. With my green line, the first equation, I started at 1 and I went up 3 over 4, up 3 over 4. With my second equation, I used blue. I started at -1 and I have a slope of 1. So I go up 1 over 1, up 1 over 1, up 1 over 1. Now notice my dot. See, they almost touch the green here, but they really do touch right there. So this is the point right here where they touch. So that point is over 8, up 7. So x is 8, y is 7. Well, I'm going to take that point and plug it into my original equations to double check to make sure it makes them both true. So watch me over here. Here I did 3/4 multiplied to 8 plus 1. So 3/4 multiplied to 8, if you cross cancel that, you get a 2. 2 multiplied to 3 is 6. So I get 6 plus 1. 6 plus 1, look at, it's 7. This next one's even more evident. X is 8, y is 7. 8 minus 7, what does it equal? 1. So this for sure is the point where they touch. Okay, so do you remember how I checked my two answers in the last two slides? Basically, these questions are, they give you a point and they want you to plug it into the equation or equations and see if it's true. If it's true, check the next equation. And if that's true, then say yes. But if you get a no, then what you need to do is just stop and say no, it will not work. So let's take the 5 and put it where the x is and put the 2 where the y is. So if I plug this in, I have 2/5 multiplied to 5 minus 2 equals 0. So I set it up like this. These two 5s will cancel. And I have 2 minus 2. Is 2 minus 2 0? Yes, it is. But I'm not done. Now I have to check this 5-2 in this equation. The 5 goes where the x is, and the 2 goes where the y is. Now let's solve this. 5 times 3 is, it's 15, and I'm going to write it down here. 5 multiplied to 3 is 15, and then I have minus 2 right here. So this is 15 minus 2. 15 minus 2 equals 13. Is that what they wrote? Yes. So if you say yes both times, then you say yes. This point does work in both equations. Let's practice one more time with this. So remember, this is x. So this is x and this is y. And you're going to take the negative 2 and you're going to put it where the x is. And then you'll take the positive 2 and put it where the y is. So now let's solve this. 3 multiplied to 2 is 6. And I have negative 2 plus 6. So what is negative 2 plus 6?
Negative 2.
Oh, it's 4. So because this first one was true, it was a yes, now we check the second one. Okay? Because if you get a no, you can stop the problem. But we can't because we got a yes. So take the negative 2 this time. This is tricky. You're going to put the negative 2 where negative x is. So it looks like this. There's two negatives. Now take the positive 2 and put it here where y is. Let's solve this. Two negatives make a positive. So what is 2 plus 2? 2 plus 2 is, well, obviously 4. But that's not what they had. They had positive 2. So this is not true. This is a no. So because you got a no, say the entire thing is no. It will not work. Alright, so we practice using graphing to solve a system of equations. Now I want to show you some special cases where when we graph them we don't get a perfect intersection. I'm going to show you what that looks like. So let's graph these two lines and see what happens. Okay, well, I did my best to graph this. It's hard to use a ruler on the iPad, but anyway, here's my red line. It starts at 1. Goes up 6. Here's my blue line. It starts at negative 4, goes up 6 over 1. If you look, especially look right here, what do you notice about those two lines? And hopefully you notice that they are parallel. So these are parallel lines. So when they are parallel, here's what I want you to say. There is no solution. That's because they'll never touch. So there is no number you can put in here to make this true for both equations. It will never work because they never touch. Now let's graph these two lines. So you can graph these using the intercepts, the x-intercept and the y-intercept. So I'll do that right now. So let's look at the red equation. I put red by it and I graphed that. I found that the x-intercept is 4, so I made a dot at 4. The y-intercept is negative 2, and I made a dot there. So watch this line. I'll do this in blue. I'm going to find the x-intercept. So remember, I'll take 0 and put it where y is. It's a cover-up method. So cover this up and say 3 times what is 12. 3 multiplied to what is 12. So the answer is 4. And then let's do this one. Let's take the 0 and put it where x is. So I'm going to cover this up. So now negative 6 multiplied to what is 12? That's negative 2. Now hold it. Look at this. My x-intercept is 4, and it was 4 on the red line. My y-intercept is -2, and my y-intercept on the blue line is also -2. So if I were to graph this, it's the exact same line. The blue line sits on top of the red line. So when that happens, here's what we're going to say. We're going to say infinite, this is infinity, solutions. Infinite solutions. It means any number you put in for x and y in the red equation will work in the blue equation. And you want to know why? The reason why is it's the same equation. And I challenge you, try and prove that these are the same equations. See if you can prove that these are the same equations. Okay? Bring that to class next time we meet. This is a real-life example of where a person could use systems of equations to find out where two lines meet or two equations meet to help you determine when you break even or when one is going to be cheaper than the other. So suppose you start planning to start taking aerobics classes, okay? All right, Christmas is over, want to get in shape. Now non-members pay $4 per class, okay? So each class is $4. Where if you're a member, you only pay $10, or you pay a $10 fee plus 2 per class. So let's write our two equations. So non-members are y equals 4x, $4 for each class. You take 2 classes, you pay $8, you take 10, you pay 40, and so on. Okay, so members pay $10 plus $2 for each class they take. So here are two equations. So we need to set up our graph and graph both equations, and we need to find out where these two equations meet. Okay, I didn't want to do the whole problem without involving you, but this does save us time. So I put fees on y because your cost depends on how many classes you take. And I started by graphing the green equation for non-members. So they pay 0. If they take 0 classes, they pay 0. But if they take 1 class, they pay 4. Notice this is discrete data. I did not connect these because you can't take half a class. So next I'm going to do my red equation for members. Here's how the red equation looked. I started at 10 because a member pays $10 even though they don't take class. They still did pay $10 to be a member. Then it only cost them $2 per class. So up 2 over 1, up 2 because we're counting by 2s over 1. Now here they touch, green and red right there on top of each other. So let's mark that point. The point is 520. There's our point. So that means if we put these numbers into the equations, we get they work for both. So they're true for both. What does the solution mean in terms of the situation? So we have to make sure we're clear that we know what it means. Well, it means if you're not sure what to write when this happens, look at the number and say, is this x or y? This is x, and then look at what you labeled x. X is classes, so just basically you're labeling. So say, if you take 5 classes as a member or as a non-member, you both pay the same, which is $20. So right here, it doesn't matter if you're a member or non-member, 5 classes would be 20. Then after that, they don't match ever again. They never touch again, okay? I included this slide for your notes just to remind you when you solve a system of linear equations, there's 3 possibilities. One possibility is that the lines touch and you have one answer, only one answer. You have an x value and a y value. The other possibility is that the lines never touch because they're parallel, and then you say no solution. The third possibility is that the lines are the exact same line. the red line and the blue line lie on top of each other and make a purple line, and then you say infinite many solutions. All right, practice problems. They're spread out a little bit, but please solve all of them. So graph these two lines and then make sure you say where they meet. That's your answer. Make sure you say where they meet, an x and a y value. Okay, same thing here. Solve these and say where they meet, and solve these and say where they meet. Lastly, take this point, -2, 1, plug it in and see if it's true in both equations. If it is, say yes. If it's no, then say no. All right, bring any questions you have to class next time we meet, and take care.